Go ahead and solve that for x. Minus 6, minus 6. 2x is greater than 12. Divide 2. X is greater than 6. Hey, ladies and gentlemen, that's an infinite number of values that are greater than 6. So solving a linear equation, I move from a single solution, a single value, to a whole part of the number line. Right? So that's what we should be looking for when we're solving inequalities, is a part of the number line. Got that in mind? Keep that in mind as we're solving these guys. Let's just go ahead and start looking at some problems. Linear inequalities in one variable. They're out of order, I guess you noticed that. You did not say that. All right, the first thing we need to address is some set notation. Some stuff we talk about, some symbols we use, and phrases we use when we talk about sets. Because we're going to be talking about sets. Parts of the number line constitute sets of numbers. There's a concept that there are concepts that blend sets. For instance, if I have two sets, A and B, I can talk about one concept called the intersection of those two sets. That symbol is used for intersection. It basically means what they have in common. And the word we use to indicate intersection is and. Just a little demonstration. All the females, please raise their hands. Okay, thank you very much. Everyone who wears glasses, please raise your hand. Now, all who are female and wear glasses, raise your hand. Okay, notice what we got? An intersection of those two sets. Not only do you fall in this set and this set, you fall in both of them, you are part of the intersection of the set. Okay? That's the first set notation. How about this one? This one we're looking at right here. And that's designated by what word?
Union.
Union, right? It's the union of two sets. And it basically means in either or the other set. And the simple word we use to describe or that shows up for A union B is or. All right? Let's do another demonstration. All females raise your hand, please. All males raise your hand, please. If you are male or female, please raise your hand. For the three of you who... There is counseling available. Everybody should raise their hand, right? Because you're in one or the other. You are in either the male set or the female set. You're one or the other, so you would have raised your hand. Everybody would have raised their hand. All right. Almost. Okay. So here we go.
Everybody's afraid of a rock being thrown out.
That's right. Or am I... Okay. So the symbol U is called a union. It's used to denote the combining of two sets, this or that.
You did? I did.
One thing we did a little bit early that they do in this section, we've already done it. We did it in chapter P. Was 3 ways to indicate infinite sets. Do you remember doing that? 3 ways to indicate infinite sets. The first one was like this. And the number line idea. The second was what we call the inequality. Well, I guess we ought to go to the interval from this guy because these are so related to each other. The interval would look like this, all right? See that? Just the good stuff out of the number line demonstration. And the inequality is, well, we're talking about all the x's in between 2 and 5, right? So x is in between 2 and 5. Areas of inequality always point toward the smaller number. So we had a number line visualization of the set. We had something we called the interval notation, and we had the inequality. Top one is, you could call it number line or graph. Notice what you got here. You've got an interval notation. Everybody see it? 70, infinity. It says write the inequality based on that. Can somebody give me an inequality statement that describes all of those numbers that are indicated by that interval? Yeah. X is greater than 7. Isn't that, in fact, if you pictured it, it's right here, it's 70 and everything to the right. So x is greater than 70. Would be the inequality notation. And if you're looking for greater than, you go to what? Relations. Here it is. Greater than 7. Y'all see where to go to the get the inequality sentence? Under relations. All right, you're not going to see this phrase, these words again on the test. I'm not even going to refer to it, but it's part of the problem. So let's talk about it. Do you think, just by the 2 words used, that this set here is bounded or unbounded?
Unbounded.
Yeah, it's unbounded. Bounded means you got a starting and an end point, right? It's a part of the number line. This is an infinite part of the number line. It's unbounded. So we're going to call this thing that never ends in one direction an unbounded interval. Yes?
Submitting the assignment, how do I get that question?
Does anybody know? You submit the whole assignment and you had that through.
I have done like,
Okay, here's what you do. You request an extension,
okay,
and I'll give you extension.
okay.
All right, let's look at some problems in this section.
Huh?
On page 146, if you happen to be following along with the textbook.
Huh?
I assume you're going to be giving us some practice problems to discuss.
Yes.
Email them out.
I'll be emailing them to you. Let's look at a very simple one like 35 on page 146. can't remember if I gave you this little bit of wisdom when we dealt with inequalities first, but did I mention in solving inequalities, it's always helpful to get the x's on the left side? Did I mention that? Some of you saying yes, understand. Let me just mention it. It's good to get your x's on the left side, even if it makes them negative. Here's one. When you finish up, you want a statement that says x is greater than something, less than something, right? You can visualize x is greater than 5. Can everybody visualize x is greater than 5? What that set looks like? You can visualize that. But if I end up with a statement that says negative 7 is less than x, going, well, where are the rest of the x? You know, I have trouble with that, and some of you do. And if you don't worry about it. But I would encourage you to put your x's on the left. Because as x is the subject of my mathematical sentence, I have a better idea about what numbers I'm talking about. So that's why I'm moving x's over to the left, even if it makes it negative. Something we typically wouldn't do with an equation. And I'm solving these guys just like I would equations. Move it, and change the sign. I get negative 2x, negative 4. Now what am I going to do?
Divide by negative 2.
And
Divide.
there you go. Very good. Everybody remember that?
Yeah.
Divide or multiply by negative. Change your inequality symbol.
Only when it's negative, right?
Only when you divide or multiply by a negative. Yeah. And it really doesn't matter if the thing you're dividing into is positive or negative. That's not the issue. The issue is, am I dividing by a positive or negative number? If it's by negative, switch the sign of your inequality. So, hey, can everybody picture x is greater than 2? Sure. You can just see where 2 is. Everything greater than that, that's my set of numbers. And by the way, the graph would have a parentheses or a bracket.
Parentheses.
Now remember?
Parentheses.
Parentheses means do not include. If I had an equal to sign under there, I'd use a bracket. All right. That's what you call an easy problem. Now let's throw in a little bit more sophistication by introducing a fraction. How about number 42? Here again is where your expertise in dealing with equations is going to come right into play solving this inequality. If you had an equation that had fractions in it, do you remember the steps we went through? What's the first thing you look for?
Find a common denominator.
Common denominator. They've only got one, so it's going to be pretty easy. What's the common denominator?
7.
Yeah, it's 7. But what do you do with that? Multiply every term by 7. You can say multiply the whole inequality, or both sides of the inequality, or every term. The result is multiply everything by 7. So every single term gets multiplied by 7. I can multiply both sides of an inequality by 7 without changing the inequality. And what happens to the 2/7 when I multiply by 7? What does it become?
Becomes 5.
It becomes 2. So I get 2x now that's a friendly looking inequality compared to the one with the fraction in it, isn't it? Whole numbers, we can handle this. According to my newfound wisdom, I moved my x's to the left. My numbers to the right.